Good afternoon, everyone. It is with great pleasure that I welcome you all to this webinar on Visualizing Science, the Art of Effective Visual Communication. I'm Rutuja Chalke, your host for this exciting journey into the world of scientific illustration. It is my extreme honor to be presenting before you all my passion for merging art and science to communicate complex information with clarity and precision. And I'm very glad to inform you that we have a total of 80 participants today who have registered for this webinar. Uh, so before we start with the webinar, I would like to thank Professor Siddharth Talur, who is the coordinator of this webinar, and whose support and dedication have been invaluable in bringing this entire thing to fruition. So before we begin, I would like to introduce myself very quickly. I'm Rutuja, as you know. I've completed my MSc in Biotechnology from St. Xavier's College, Mumbai. I started my professional journey as an academic editor, and I simultaneously did a course in graphic design, post which I entered the world of the design as a UI/UX designer. I worked in an e-learning company for a while as an illustrator, and before I started working as a science illustrator. So now I'm a full-time science illustrator and as a freelancer as well. So as a freelancer, I have interacted with several researchers and institutes around the world, and I help them to convey their scientific information with the help of engaging visuals. So it's a very well known fact that our brain can process visual information much faster than textual information, which explains the importance of visuals when it comes to communicating scientific information. So before I define scientific illustration, I would ask you all to have a look at this graphic and let me know what it tries to explain to you. I'll just zoom in a bit for you to read it properly. You can take 1 or 2 minutes and you can turn on your cameras or you can type in the chat section below and let me know how this is explaining you the entire process. Okay, let's see if anyone has tried out any answers now. You can let me know in the chat section what you understood from the graphic.
It is the process of photosynthesis, and your the graphical representation is at each step, and it's basically illustration of the how the reaction is mentioned at the bottom. So that stepwise it is graphically represented what happens at each stage, and finally what you get an output in the statement of in the form of a reaction.
Exactly. So this is basically explaining the entire process of photosynthesis with the help of just one simple graphic and with some minimum text which conveys what happens at each step in the process. So scientific illustration is basically a way of communicating scientific information with the help of simplified visuals which are still engaging and attractive. So there are two methods to create a scientific illustration, traditional and digital. So in the past, the pen and paper method has been used. But as we all know, now everyone prefers to use digital softwares to create their illustrations for their publication or for any other purpose. So this entire field of scientific illustration, we can divide it into a few categories depending on where it is applied at different stages. Illustrations for publications or presentations. There's graphical abstract or the TOC graphics, infographics and posters for data visualization, and for scientific animation. So now let's go ahead and learn a bit more about each of these categories with the help of some practical examples. . So here's an example of a scientific illustration I had created a few years back for a publication. Now, please take your time and go through it, and you can again let me know what you understood through this entire illustration. You can feel free to mention in the chat box if you're not comfortable with uh, turning on your cameras or speaking out. Okay, you need not go in the details now, but would anyone like to give an overview of what they're trying to explain through this graphic?
So it's a, I mean, not going in the detail, it is the entry route for SARS-CoV or COVID-19 virus as such, various entry routes. And it's like a comparison, what happens or the, I mean, healthy and the patient when when the virus attacks through various routes. It's
Yes. Yeah, so it is basically explaining the entry route of the SARS-CoV-2 virus and how it leads to system-wide dysfunctions. And they have divided the entire illustration into two sections. One is neuroinvasion and the altered homeostasis. So the different paths through which it enters our nervous system and then how it alters the homeostasis. So, what are the things that you think in this illustration are conveying the message clearly?
I think the healthy and the image of that lungs and the deceased really gives you a very good comparison if you're not even reading the other part. But yes.
Exactly. Yeah, and then dividing the entire process into different sections. They have labeled it A, B, C. So it's very easy to go step by step in sequence and understand the entire process. But like you said, the images of healthy subject and a COVID patient, that clearly draws your attention first when you look at the graphic, and it conveys the message even if you don't read the entire illustration or you don't go through it. So that's the power of a scientific illustration when you are trying to explain a broad concept like this. So basically, for publications, it will be explaining an experiment, a concept, a theory, or a hypothesis that you are mentioning in your paper. But the most important thing when you're creating a graphic for your publication is to understand the journal guidelines. So every journal provides a set of guidelines for your illustration. It could be the dimensions that need to be followed for the graphic. So the height and width of the illustration, the font or the font size that is to be used. So it is legit when it gets printed in your manuscript. The colors that you're using, the file format that is acceptable. So like in most cases, it is PNG, JPEG, PDF. Depending on journals, they have different set of guidelines for your graphic. So before you start working on your illustration, it's very important to go through the journal guidelines. And I would like to ask you all, mostly researchers who have actually worked on your own papers, what are the things that you do, or what are the things that you go ahead when you're creating your own illustration? Because not everyone is well equipped with this illustration skills, and not everyone will go ahead and create it from scratch. So what are the things that you prefer when you're creating a graphic for your illustration or any graphic in general? Okay, so let me put it this way. You can let me know in the chat box. Do you guys go on Google and search for images that will explain your concepts? You can let me know in the chat box, yes or no.
Yes, actually, we'll just find out the images required for our procedures, and then we'll try to merge them to show whatever work we have done that matter.
Yes, so I think most of us usually the first thing that we do is go on Google and we look for images that will help us explain our work. But no matter what image we are using, or even if we are using a vector from some free source, it's very important to give attribution to these images or vectors, especially when they are being used in for a scientific publication or a presentation. So these are the things that need to be considered when you're working on your own illustration for a publication. So now I would define scientific illustration as the perfect blend of scientific accuracy and design principles. So obviously the illustration needs to be scientific accurate because you're presenting the information to a wide scientific community, and it needs to also be in compliance with some basic design principles. Now, as someone from the science profession, you may not be aware of the principles of design, but it's important to consider some basic principles like the font and the font size that you're using, the type of colors that you're using for your graphics, and again, the size of your graphic and how you're organizing your entire graphic into different section. That will define how well you are conveying your information through your illustration. So these two things are very important whenever you're creating your own illustration. So since not everyone will be aware of how to start with your own start creating your own graphics, so I would suggest it to make it a 4-step process. So the first and most important thing is knowing your concepts very well, which is how you will be able to convey it properly with your graphics. Then you can go ahead and make a rough sketch of your graphic. So you would that would help you to create a more organized structure for your graphic, and then you can go ahead and select a tool of your choice to create the digital illustration, or use some online tools which also provides with some vectors which you can directly use instead of designing it from scratch. And then you can go ahead, refine and make it perfect till it exactly conveys the message that you're trying to say. So it becomes a very easy process when you when you start creating your illustration in an organized way like this. So before we talk about graphical abstracts, I would now again ask you to have a look at this example and let me know what you understand through this. Or what do you think is lacking in this illustration?
Details are
Is it annotation?
Exactly. Details are not clearly mentioned here. So now let me explain this graphical abstract. In this work, they're basically trying to introduce a new updated version of their software called Anti-Smash, which helps in identifying and categorizing certain gene clusters, which encode for compounds like antibiotics, food preservatives, crop protection agents, etc. But as you see, when you have a look at this graphical abstract, it is nowhere mentioning the message clearly. But now, if you have a look at this graphical abstract, let me know what you understand through this figure. You can type in the chat box if you're comfortable, or you can turn on your camera and say what you understand through this graphic.
Probably they are trying to analyze some microbial culture, like finding the gene sequence from wastewater, like some microbes. Uh,
Yeah. So as you see, the graphical abstract here is divided in 3 sections. The first section talks about the sample where they collect the wastewater sample. Then they process it through heat activation. The second section here talks about 2 different methods that they have used to extract nucleic acid from this sample. So basically, this work is about introducing 2 new methods, the dipstick method and the PMF method. So they talk about the steps that they follow in this procedure. And in the third section, they're explaining their data. So basically, they're trying to convey that the methods that they have developed, the recovery efficiency of this method is comparable to the commercially available kits. So the main hero of the graphical abstract here is the dipstick method and the PMF method, which is clearly mentioned in the center. So as you see, creating different sections for your graphical abstract with the help of minimal text and some very basic graphics, it explains your entire research work with just one illustration. So graphical abstract basically is a summary, a visual summary of your paper, which will convey your entire work with just one figure. And again, in this case, it's very important to follow the journal guidelines, like I mentioned earlier, the dimensions, the file format that is acceptable by each journal, the font size, and so on. And again, it's very important to attribute the images and vectors that you're using in your illustrations. Now, if you wish to create your own graphics, these are some free illustration tools available. You can go ahead and explore these. And there's also an AI tool that I came across recently, which is called Lab Canvas. Here you can submit your graphical abstract and it gives you a detailed review of your abstract. So how you can improve it design wise and even with respect to the content that you have added in your graphical abstract. So do check this out, and also you can go through these tools and try creating your own illustration next time. Now let's talk about infographics and posters. I'm sure most of you have to design your posters for conferences or whenever you're presenting your work. So here's an example of an infographic I had created recently for a company called Prescience in Silico. Here they were trying to basically explain the services that they offer, as you see clearly. I can zoom in a bit for you to read it clearly. So basically, an infographic like this would be a combination of text as well as a graphic. So they have explained their services through text, and there's a graphic in the center which basically provides a summary of all of these. So an infographic or a poster will be a combination of illustrations and textual information. Now here are a few examples of infographics and posters. Let's zoom in into each of these and understand what they're trying to convey. So if you have a look at the first one, this is posted for a conference I had created last year for a startup called Clarity Biosystems. So here they're basically trying to explain their product, what are the services that they offer. So here, as you see, they have clearly divided their entire work into sections. They are explaining where it helps, the strengths of their work, what are the services that they're offering, case studies, and some contact details. So as you see, they're not giving all the technical details of their work, but it is enough for someone from a science background to understand the kind of work that is being done. So in this case, their audience would be someone from the scientific profession or a business profession who is interested in collaborating with the startup. So the language and the kind of graphics used are added in such a way that it could be that it is understandable for someone from a scientific profession, but still not giving out all the technical details of their work. Now, if you have a look at this aspire infographic, it is basically introducing an instrument that was developed by a researcher from our lab. So here we are divided the entire infographic, as you see, into some simple sections. First, we talk about the history, that is the origin of idea, how we started with it, uh, how it was developed. Then we talk about the innovation, the technical specifications of the device, the features and controls of this device, and then again some information to know more about the device. So now if you have a look at this language, this is again for someone who is from the scientific background, who would understand the technical details that are mentioned here. Yet it is provided in very simple manner without giving out all the details of the work. So this is how, with the help of graphics and text, an infographic can convey all your work in just one page. Now, if you have a look at the third one, which talks about avoiding antibiotic use, if you go through the text and if you have a look at these graphics, it's easily understandable that this language is for someone who is even not from the scientific background. So a person may or may not be from a scientific background, but there are times when we have to convey our work even to the layman. In this case, the language needs to be modified accordingly, and the graphics that we use needs to be presented in such a way that it could be understood by it can be understood by anyone. So as you see, we have clearly talking about what are antibiotics, what is antibiotic resistance, and then we talk about the side effects and how to avoid the use of antibiotics. So this will clearly explain antibiotic resistance to someone who is even not from science background. So now, what we could summarize from this is, depending on your audience, the content that you add in your infographic and the language that you use, the illustrations that you add will vary according to the audience that you are creating it for. Like you see, for conference or for any other scientific presentations, the language and the illustrations would be more detailed and more precise. Whereas for the layman, it would be much simpler with the help of less graphics and very simple text. It can explain the entire concept in an infographic. So as I mentioned earlier, it's very important to know your audience when you're creating any illustration or any infographic or poster. So your audience could be a science professional, a business professional, and a layman, as in the examples we just saw. So according to your audience, the content and the language that you use in your infographic or poster will vary. These are some of the free online tools that you can try out to create your own posters or infographics. Napkin AI is a new AI tool which converts your information into an infographic. So you can definitely try out this one too. Now let's talk about data visualization. So as we know, it's basically the art and science of communicating your complex information in a simple manner. So you're basically transforming your scientific data into a visual with the help of any type of chart. So here's an example. These are some STEM images from a certain research work. So have a look at it and let me know now what you're understanding through this. CNF here stands for carbon nanofibers. Um, so yeah, take your time, go through this and let me know what you're understanding from these images. Would anyone like to give a try?
Like we can see like two forms of the CNF, uh, like functionalized and raw.
Yes.
It's like a experiment being conducted, and these are like electron micrographs.
So basically they're observing something after a duration of 2 hours, right? This is all we can understand when we look at these same images. But now when we look at the entire image, when we add some data visuals with this data to, so it will help us understand the entire process in a much better manner. So now have a look at these graphs and let me know how it is explaining the images better way. The figure legend also clearly explains the process now, but you can have a look at the graphs and see how it is conveying your data in a much better manner now. So would anyone like to explain this?
The difference in their average diameter after getting functionalized is very
Yes,
much reducing.
exactly. So it's very much clear from the graphs now that in case of the raw CNF, after a duration 2 hours, there was not much difference in the diameter. Whereas in case of functionalized CNF, after 2 hours, there was a noticeable change observed. So no matter if we don't understand the entire work or the entire research paper, but with the help of these visuals, it is definitely explaining the SEM images in a much better manner. So this is the importance of using visuals for explaining your data. So there are several free tools available for data visualization. I'm sure most of you have used Excel for plotting your graphs or other data visuals, but you can also check out these free tools like Tableau, Orange, and Click, and you can use it the next time you are creating visuals for your data. Okay, so before explaining something about scientific animation, this was just an example for you. So would anyone like to speak up and say what they understood through this animation?
So this was about sickle cell anemia and how does it happen, the central dogma process of causing a mutation, and then how the RBC is changing its shape and how it is differing from the normal RBC.
Exactly. So we saw like with the help of some basic visuals and some minimum text, how we can explain the entire concept of sickle cell anemia through a very small animation. So these are some free animation tools available online. You can definitely go out and explore in case you're planning to explain your work through some great animation. Now, I hope I have intrigued you to know more about this field of scientific animation. So if anyone wishes to pursue a career in this field, you can definitely look into some bachelor's or master courses that we have abroad. There are some online courses that you can try out to know some basics of design. And one thing I would suggest is to keep learning and to keep updating yourself with trends in this field. If you really want to know more about scientific illustration, or even if you don't want to pursue a career, but you wish to learn a few basic skills that you can use in presenting your research work, I would suggest you to connect with illustrators through LinkedIn and other social media platforms. And you could also join some communities like the Guild of Natural Science Illustrators and AMI to keep learning more about this field and to develop some basic illustration skills that you can use in your work. And in case you really look forward to pursuing a career in this field, these are some of the top universities abroad. This is not a redundant list, but you can definitely look into these courses and you can try applying for it in case you're really interested to pursue a career in this field. And unfortunately, as you see, there are no universities in our country which offer these courses. So my goal for today's webinar was also to create more awareness about this field of scientific illustration and to explain the importance of visuals in communicating your scientific information. So in case you're interested to know more, you can join the Discord community and introduce yourself, and you can let me know if you have any doubts or if you'd like to know more about these universities or any other tools that I mentioned earlier. I would definitely like to share the links with you. So thank you everyone for your patience. These are the references that I used. And I would request each one of you to please share your feedback by filling this feedback form. And you can always feel free to reach out to me in case you have any doubts or if you'd like to know more about scientific illustration. And even if you wish to share any recent work that you're doing and you need a feedback, you can definitely communicate in the Discord community that we have created now. I'm looking forward to add some more tips and tricks that will be useful for researchers for creating their own illustrations. So I'll also be sharing the link for the feedback form very shortly in our Teams. And in case you guys found this webinar interesting, we are also planning to have some workshops in the future. So each dedicated workshop for graphical abstract, for data visualization, image enhancement, and a few more as well. So in case you want to know more about this workshops, you can start interacting with us in the Discord community, and we'll be glad to give you more details about it. So that's it from my side for the webinar. I'll ask you to, you can go ahead and ask your questions, or if you would just like to share your experience, how you found this webinar, please go ahead.